but there also exists at most one solution. So again, there exists a unique solution is the economic way of saying it. The actual logical implication is that there exists at least one real solution, but that can also be at most one solution, which means there is only one solution. As long as this is true, all future cash flows are non-negative. In fact, we have a name for this. These are called conventional cash flows. There is no closed form formula to find the IRR, but Excel does have a function. We could also do it using GoalSeek, but Excel does have a function. And you probably guessed the name of the function. Exactly. And let me do this different font. The IRR function technically has two arguments. The first argument is starting with the year zero, all the cash flows. The fact that I have zeros afterwards doesn't matter. Let me see, actually. Just a second. I need to cancel these. For IRR, to make sure that you zero any superfluous numbers. We could also use the GoalSeek, but I'm not going to worry about it too much. Technically speaking, IRR has a second argument, IRR function. Since Excel figures that out using a numerical algorithm, which always have a set of iterations, it starts from an arbitrary guess and it improves upon it. You can provide that guess yourself, 0.1, but that's optional. I put that there on purpose, which we're going to kind of touch in the second half. Again, in terms of IRR rule, accept a project if it's standalone, if IRR is greater than the discount rate. Okay. So your rate of return is greater than the required rate of return in a sense. Reject otherwise. For mutually exclusive projects, you guessed it, accept the project with the highest IRR, provided it is greater than R. That's pretty much it. I don't have to mention IRR does not know anything about the scale of the problem. So when projects are mutually exclusive, let me change this. Let's make this a 2-year project. Let me divide that 40 into 25 and 15. Okay, this project has an IRR of 2374. Let's go back to that 90,000. 45. Okay, this is 65. Well, let me do 65. 45. What was the other one in terms of IRR? It was a little bit bigger. Anyway, we'll get back to it. This project has an NPV of about 6,300, IRR of 15.5. The other one was 30, 25. It has a huge IRR, 23% compared to 15. So IRR rule says pick this project, but NPV rule says pick the first one because it was 6,300. Again, same issue. IRR does not know anything about the scale of the problem. It's a per dollar return kind of number. So you don't want to use it for mutually exclusive projects. Now, I'm going to mention one thing, then we'll give a break so that we can deal with it after the break. If the cash flows are not conventional, which means there exists at least one year with negative cash flow, and the equation that defines IRR typically has multiple solutions, multiple real valued solutions. And there always exists n solutions, but some of them could be complex or imaginary. In fact, the number of real valued solutions is as high as the number of sign changes. Let me tell you what I mean by that, then we'll give a break. Suppose this was a 3-year project. I started with negative, then a positive, that's one sign change. So let's do negative 15,000 here and 30,000 here. Negative to positive, positive to negative, negative to positive. So there are 3 sign changes. That means the equation that defines IRR may have as many as 3 solutions. In fact, look at it. IRR, let me do it with no initial guess, 1524, okay? Let me do an arbitrarily high initial guess, 0.99. Okay, that's also the same. How about if I do negative 0.99? Or let me do something different. Okay. So 0.1 negative 0.1 gave me 30.59. Oh, here it is. If I started the algorithm that calculates the IRR with negative 0.9, negative 5739 is also a solution to that equation. In this case, the number of solutions can at most be 2, so I know both of them. It's either 30.59 or negative 57%. So when there are multiple solutions, the entire concept of internal rate of return loses its meaning. Which one is the internal one? So it's a totally useless concept. So you never use IRR when the cash flows are not conventional. But there's still a kind of modification of that that's going to be helpful, which we're going to talk about after break. Let's get back here at 7:35. All right, let's resume. Okay, as we have seen, there are issues with IRR when the cash flows are not conventional. What we do, if you insist on using something like IRR, we're going to do something called modified IRR. Or MER. It's basically, your book defines 3 different ways of doing it, but I'm going to do only one of them. It's basically calculating IRR for a modified set of cash flows. What we're going to do is, if a future cash flow is negative, modified cash flow for that year is 0, but present value of that cash flow is added to the period 0 cash flow. So think of a negative cash flow in the future as a delayed cost. So I'm going to calculate the present value of that, bring it to today, and make the cash flow for that year 0. And we can easily do that in Excel using 2 very useful functions. That's what I love about Excel. Let's call this modified cash. And I'm going to use this format just for color. Let's actually make that light pink.